A widely repeated reference line gives one fictional creature a body temperature of 18,000 degrees Fahrenheit. Converted properly, that is 10,255 Kelvin, and because nobody ever converts it, the hobby passes it along like an ordinary stat. Start at the bottom, because Kelvin counts up from absolute zero. A cold room is 283, boiling water is 373, so everything you have ever touched sits inside a factor of 1.3. A wood flame runs near 1100 Kelvin and basaltic lava near 1400. Both of those are ranges rather than fixed numbers, so each pick is stated, because a ladder built on unstated picks is not an argument. Molten steel is tapped at about 1600 degrees Celsius, which is 1873 Kelvin. A light bulb filament runs near 2800, and that is roughly the ceiling for anything still solid. Tungsten has the highest melting point of any element, 3695 Kelvin, and it boils at 5828. The sun's surface, 5772, falls between those two, which means tungsten would be a liquid there. Now the stated figure. It is 1.78 times the sun's surface, and radiated power climbs with the fourth power of temperature, so that is very nearly 10 times the emission from every square meter. Stefan Boltzmann gives the rest. Power is sigma times area times temperature to the fourth, so assume 1 square meter and a perfect black body, and it pours out 627 megawatts, which is a mid-size power station. Spread that over a sphere, and the intensity falls with the square of the distance. Take severe burns as 1,000 thermal dose units over 5 seconds, so the burn radius comes out at 31 meters. At 191 meters, it is only noon sunlight. But cut the exposure to 1 second, and the same temperature gives 17 meters. Give it 10 square meters instead of 1, and it gives 97. The temperature never settled the radius by itself, and the temperature is the only number anybody quotes. Keep climbing anyway, because the stated figure is nowhere near the top. A lightning channel reaches about 30,000 Kelvin. The hottest measured stellar surface is about 210,000. The sun's core 15.7 million, and a supernova core about 100 billion. So the figure is not absurd, it is incomplete. A temperature is a property of surface, so what it does to you depends on how much surface there is and how long you stand there. Your ranking in the comments. You already have one.